Eran is coming from the DDR&D, the army. Eran is the head of the digital and data branch, so he knows a little bit about AI. Maybe he can share something, but I think the focus of Eran's talk is about the junction where cyber, AI, and cloud meets all together from the perspective of the DDR&D and the way you see the future, and maybe you can ask them the same question.
Hello guys, how are you? Good. They told me there to woke you up, so here I am woking you up. I'm very happy to be here today and to discuss you about the junction between the cyber and AI as I see it. While preparing this presentation, I thought why not bringing in our third friend to the presentation. So I will also discuss today about the junction between cyber, cloud, and AI. And this will be the main topic of this presentation when the three giants meet. So as they said, my name is Eran. I have a PhD in the AI and electrical engineering. I am the head of the digital branch in the DDR&D. For who is not familiar with, the DDR&D stands for the Directorate for Defense Research and Development, which is a unit inside of the Israeli Ministry of Defense. Partly military, partly civilian. I'm coming from the military unit. We are responsible for all the research and development for the use cases of the IDF, as well as leading a very big project for the Ministry of Defense. So as we start, I will start with describing a bit about our cloud strategy. As you know, the Israeli Ministry of Defense, as well as other agencies in Israel, works a lot in the cloud, and we have our own cloud strategy, with divided to three. In the left side here, you can see our on-premise private cloud, which is the state-of-the-art technology that we can get from different vendors around the world and in Israel. It's self-built with different vendors in the Israeli market and being deployed and managed by our expert officers and soldiers. In the middle, you can see our hybrid cloud, which really stretched out different workloads, heavy workloads that we have in our on-premise private cloud to a very, very secure location and environment inside of the cloud, and then relies on different infrastructure of the vendors of the cloud. In the third part, you can see the secure public cloud, where we use an unclassified data and materials in order to rely on the SaaS services that the cloud can offer. But as I said, that the Ministry of Defense works a lot on the cloud. It brings a lot of challenges, of course, because cyber defense in the cloud is very, very hard, because you stretch out and maximize the different attack vectors of your attackers, and a lot of people want to attack, of course, the Ministry of Defense and other agencies in Israel. So first of attack vectors, it can be an unknown attacker from an unknown network, and you need to be defended from it. Another attack vector can be an endpoint attacker, in this case, an attacker that sits next to Bob and uses the access that he got in order to gain access to our workloads, data in the cloud. The next attack vector can be a trusted environment or SaaS, even if it's SaaS from your CSP or third-party SaaS in this case. While you use it and you send your data and your controls, of course it can harm and manipulate your data. And of course the man-in-the-middle attacker, which will always be a bidder, and you need to be defended from. And in this case, even an attacker from your own CSP and your own environment, which got access to your VPC or to your workload. So those are all of the different attack vectors, and we need to be defended from all of them. And while talking about defend, usually we split the word to three vectors or portions. One is the confidentiality, the integrity, and the availability. Different companies come with different solutions that try to maximize this triangle for different use cases. From our approach, one of the biggest, and we want to maximize the target of confidentiality for our use cases. And this is why the way that we are building our landing zone or solutions is based on this maximization, as I said. But the AI comes with a lot of potential to defend our own cloud. So the junction between the cyber and the cloud, as I said, brings a lot of new cybersecurity threats. But using AI smartly, and I will show you a few potential use cases of using this AI smartly, you can better secure your environment, have better system optimizations in terms of your defend vector, and of course have better application adaptation to specific defend your environment or your application. In this slide, you can see some of the R&D vectors we are now deploying, developing inside of the DDR&D in my branch. And of course, there is a different vector for each threat that I discussed before. So for the end user, we are developing a secure remote endpoint to securely get to our own assets in the cloud. In terms of the local regions in Israel, we are developing a QKD. I will describe it later. You see a circle on it. So a QKD stands for quantum key distribution. We will talk about it later. Of course, we are using all the defense in the different platforms that we are using, whether it's Azure, GCP, or AWS. And the public domain vectors, which contains the code supply chain, defend, the data confidentiality defend, using enclaving machines, VMs, and confidential VM, and LLM API clearance, which I will discuss a bit later. So talking about QKD, so QKD stands for quantum key distribution, which really relies on the physics of how you can distribute keys using quantum optics. And the idea is how you can eliminate or minimize the attack vectors of man in the middle. Here, what we are doing in my branch, in the DDR&D, we are now developing a QKD from a secure location inside of one of our bases in the Ministry of Defense, and applying this QKD to one of the regions in Israel, as you can see here. And then each key that is being distributed from a secure location directly to the cloud environment. And from there, it can be distributed to different SaaS services in the cloud. As you know, post-quantum decryption for different encryption and transmission can be decrypted using quantum computers. And part of the solution is to use quantum key distribution in order to manipulate and minimize the post-quantum threat. So this is what we're doing in the world of QKD inside of the Israeli region of the vendors. As I said, LLMs can be used in different applications for cyber defense. Here in this table, you can see different applications that ChatGPT can help to solve. In my opinion, one of the most interesting one is the anomaly detection, because usually in order to do good anomaly detection, the researcher needs to be an expert in his application, in his APIs, and also in the context of what he wants to defend, and it's very hard. But now the latest LLMs have a very big contextual and context windows. So those big context windows can help the LLMs to learn a lot about your environment, to learn a lot about what you're trying to defend, and from there to help you to detect anomalies in your environment. But as you can see here, a lot of other applications are also applicable, of course. Here is a draft of how you can use LLM agents, and this is part of the projects that we are now developing in order to better defend your environment. So actually this architecture is built from 4 components. And I will go over each one of them. The first one is the API LLM, which is a large language models that relies on different agents. The agents needs to better learn the CSP documents, the versioning of the APIs that you are using, and to store all of them in such an API database which has information and also called a snipset. The second part is the conversational LLM that helps the researcher in order to gain more insights about the API researching. So as a ChatGPT style chat, LLM can learn from all the API database that have been collected in order to help the researcher. This is what you see in the right side of this slide. The researcher LLM is automatically learns from the API LLM about new APIs and then test them with scenario agents and resource allocation agents that goes to the cloud and automatically create resources in order to test those APIs. And in the left side, you can see the expert LLM that mimics known successful attacks from the researcher's work, as well as website attacks. And with reinforcement learning method, tries to approach the researcher LLM in order to find new vulnerabilities and new attacks. I don't know if anyone saw it, but actually Google just announced a week ago about a very similar architecture for finding vulnerabilities with LLMs. So this is one of the biggest projects that we are now developing for cyber defense in the cloud. In the last minute or so I have, I want to share with you a few ways to join us to this insightful journey. We are now having 2 different call for proposals. You can scan the QR code here to link us. One is a call for proposals specifically for the academia in Israel and abroad in order to have unique solutions in research for cloud security research. As I said, you can scan the QR code to connect us for this. The second one is very unique, I think, because we are going to do soon competition, CTF-like competition, which will be prize money for it, which allow investigators and researchers to connect to our own cloud and try to find vulnerabilities and attacks. Here you can join the mailing list and we will approach you when this competition will be deployed. That's it. I think it was a very interesting topic. Thank you very much.
Thank you, Eran.
Thank you very much.
No question for this session, sorry.